A sledge of mass 39 kilograms moves on a rough slope inclined at an angle alpha to the horizontal, where tan alpha is 5 over 12. The coefficient of friction between the sledge and the slope is 0.3. Given that the sledge is moving freely down a line of greatest slope, calculate the magnitude of the acceleration of the sledge, giving your answer correct to 2 decimal places. Given that the sledge is being pulled up the slope with acceleration 0.4 meters per second, by means of a rope parallel to a line of greatest slope, find the tension in the rope. So we've got two separate problems here then, haven't we? I've summarised the question here. Tan alpha is 0.5/12 and mu is 0.3, the coefficient of friction. The weight of the sledge is 39 kilograms. So we first need to, it's moving freely down, so it's going to move down under its weight, isn't it? So this is 39 mg. Then we've got a reaction here. Let's put it in. Perpendicular to the slope. This would be R, which I've labelled it there. And then there's a resistance, isn't there? As it goes down the slope, it's going to have a coefficient of friction is 0.3, so this is 0.3 R. So we'll apply F equals ma down this way, and we'll apply F equals ma. There's no acceleration, so the resultant force is 0 in this direction, isn't it? So the angles, let's just do tan alpha. The tan of alpha opposite over the adjacent, so it's a 5, 12, 13 triangle here for the trig values for alpha. So, okay, this is alpha, this is 90 minus. This will be alpha then, won't it, in here. Okay, good. So let's have a look at A. So let's resolve the forces and apply F equals ma in this direction. There's no acceleration, so the resultant force will be 0. So R minus, and this is the opposite direction, 39g cos alpha. Cosine alpha is 12 over 13 equals 0. That tells us that R is equal to 13 into 39 goes 3. 3 12s are 36. Move this minus over to a plus. 36g newtons. So there's the acceleration. We need to find it. There's the reaction force rather. So if we go down in this direction now along the slope, the line of greatest slope, and apply F equals ma in this direction then, see what we get. So here we'll have 39g cos of this angle, which is sine of this angle. Sine of the angle is 5 over 13. So minus the resistance force 0.3 R is equal to the mass, which is 39, times the acceleration down the slope. 13 goes into 39, 3, and 3 5s are 15. So 15g minus 0.3, we can write as 3/10 if we're just doing it in our heads. R was 36g. There's R there, is equal to 39a. So that tells us then 39a, just writing it the other way around. This is 3 36s is 90, 3 6s are 18, that's 108 over 10, 10.8. So we've got 15g minus, this was 108, 3 36s over 10 is 10.8. So this will be 4.2. So that tells us the acceleration then. 4.2g divided by the 39. Move the 39 from times down to divide. So let's tap that in the calculator then. 4.2 times the 9.8 divided by 39. Decimal. We need it to 2dp, 1.06. 1.06 and that's meters per second to 2 decimal places. Okay, that's part A done. Now let's have a look at part B. We'll put the forces, we'll use the same diagram, but we'll put the forces in a different colour. So now it's being pulled up the slope with a tension in a rope parallel to the line of greatest slope, isn't it? Parallel to the line of greatest slope. So there's the tension in the rope. It's being pulled up, and it's got an acceleration of 0.4 meters per second. The weight still acts down. The resistance component, this is still the same, isn't it? There's no change to that. But instead of the resistance force acting in that direction, it simply acts here, 0.3 mu r. So for B then, bearing those thoughts in mind from the picture, let's resolve the forces in that direction up the slope then. And apply F equals ma. And that gives, so it's the tension in the rope minus the resistance force, which we said was 0.3 r, minus the weight component, isn't it? So let's go back. Tension minus the 0.3 r, which we put in, minus this weight that component acts in this direction of 39g cos this, which is sine alpha. 39g sine alpha, 5/13. 39g is the weight, and then sine alpha was 5/13. So there's the resultant force is equal to the mass, 39, times the acceleration. Let's just go back up and check what the acceleration is. 0.4. And the sine was 5/13, as we said. So this is 0.4 or 4/10. So we know r, so we can get the tension then. Because r doesn't change from before, is 0.3 times r, and r was 36g. 36g is r. So we moved this over the equals and put it as a plus, and replaced r by 36g there. Plus, this goes into this 3 times, so it's plus 15g, plus the 39 times 0.4 that's already there. We need to tap this in the calculator and see what we get. So 0.3 times 36 times the 9.8 plus 15 times 9.8 plus 39 times the 0.4 equals 268.44 newtons. That's the tension in the rope.